All right, this is Dr. Michael Baker, and this is my presentation over heuristics, errors, and biases. This is the second part of Chapter 5. This chapter in general covers social cognition. So, I had mentioned in my first part of this chapter, my coverage of the first part of this chapter, that people are cognitive misers, meaning that they don't like to use a lot of energy for making decisions and just thinking. So we rely on heuristics or mental shortcuts. And these strategies for arriving at conclusions are certainly fast and to some degree they're very efficient, but unfortunately a lot of times they're also inaccurate. So I would just want to run through a couple of commonly used heuristics and just give you a couple of examples of where they can go wrong. So first we'll be talking about the representativeness heuristic. With the representativeness heuristic, people judge the likelihood that something is true by the extent that it resembles a typical case, or you might be judging the likelihood that somebody fits into a particular category of people based on the extent to which they resemble a typical member of that category. And I know that this textbook definition is kind of abstract and maybe a little confusing, so let's look at an example. So let's say that there's a woman named Rachel who wears glasses and does not own a TV, right? And you have to decide which is more likely. Do you think it's more likely that Rachel is a librarian, or do you think it's more likely that Rachel is a Texan? So what most people would do is just very quickly they would think of, what is a typical librarian like? Probably come up with a mental image of a bookish person wearing glasses, reading a lot of books, and a typical Texan. So you can see stereotypes kind of play a role in this. So you might think of somebody who's wearing cowboy boots and they're outdoors a lot. And so a lot of people would probably jump to the conclusion that Rachel is more likely to be a librarian just based on their mental image of what is a typical librarian and what is a typical Texan. However, if we actually run some numbers, we can find out that Rachel is actually more likely to be a Texan. But the big question is, well, why is that? So let's just take a look at the base rates. This is actually related to another problem in thinking called the base rate fallacy, where people fail to take base rates into account. So let's look at the total number of librarians in the United States. So that is about 148,960. And if you look at the number of Texans, these numbers might be a little bit out of date, but it's just under 25 million. So that's a big difference in the overall numbers here. Now, let's assume that the Texans kind of fit the national numbers here. So let's say about half of Texans are female, about 19% wear glasses, and about 19% of Americans wear glasses. And only about 1% of Americans don't own a TV, so we'll say maybe that applies to Texans too. Then if all those are true, then about 235,432 Texans could fit the description, right? So even if we assume that every single librarian in the United States is female, wears glasses, and doesn't own a TV, and those numbers are probably not true. There are a lot of librarians who are male, who don't wear glasses, and who do own a TV. But even if we did make that assumption, that all of those librarians could fit the description, then the number of Texans that could fit the description is still larger. So once you take that base rate into account, you can see why it's more likely that Rachel is actually a Texan, and it's just due to the fact that there are so many more Texans than there are librarians. So, another heuristic that we'll talk about here is the availability heuristic. Right? So, whoops, sorry, my slides kind of went off on their own here. All right, I'm not sure what's happening there. Something got automated, but let me see if I can make this work. All right, so the availability heuristic occurs when people judge the likelihood that an event will occur by the ease with which they can remember similar events happening. So if you have to think to yourself, how likely is it that something will happen, you look into your memory and try to think of things like that happening. Now, the classic example of this is people's ideas about how likely it is that they would die in a plane crash versus how likely it is that they'll die in a car wreck. Well, most people tend to be more fearful when they get into a plane than when they get into a car. And, a lot of times people who know the statistics will try to calm those folks down by saying, oh, don't you know it's just hundreds of times more likely that you'd actually die in a car wreck on the way to the airport than by dying in a plane crash once you get on the plane. Because of the fact that car wrecks happen so much more frequently than plane crashes. But that doesn't tend to calm people down very much. And the reason for that is that our memories of plane crashes tend to be very vivid because of the fact that they are so violent and dramatic. If a plane crashes in our town, which I'm teaching in Greenville, North Carolina, if a plane crashed here, it would be on the news. Even if a plane crashes anywhere in the United States, it typically makes the news, particularly if it's a large passenger plane. And so you'd be very likely to hear about that. Car crashes happen all the time. I mean, every day there are people dying, hundreds of people dying in car crashes. But that doesn't get covered on the news. So even though it's more likely to occur, it's less likely to make it into your memory. Whereas, the coverage of the fiery plane crashes tends to be something that's just more likely to stick in your memory and be easier to pull out, so that when you step on a plane, all those memories that you've seen of real plane crashes and, of course, fictional ones in movies, they come flooding in pretty easily. Now, every time you get in a car, all of your memories of car crashes and death by car crash, those usually don't come flooding in just because they're less available, less vivid. So, another heuristic we'll talk about here is the simulation heuristic. And with the simulation heuristic, we judge the likelihood that an event will occur by our ease of imagining it. Now, it's very easy to get the simulation heuristic and the availability heuristic confused with one another. The availability heuristic is based on something in your memory, so your actual memory for things happening. The simulation heuristic isn't necessarily based on memory. It's based on your imagination. So you're not remembering things that have actually happened. You're imagining something happening. Right? So one classic example of the simulation heuristic, or that relates to this, is the satisfaction of Olympic medal winners. So if you think to yourself, well, who's the most satisfied out of all the medal winners? The gold medal winner, the silver medal winner, and the bronze medal winner. Well, it's obvious the gold medal winner is going to be the most satisfied because they won the best possible prize. But who is the second most satisfied? Well, that's when things start to get interesting. You might think, well, second place should be the second most satisfied because they got the second best award. But what researchers have actually found is that the bronze medal winners are actually more satisfied than the silver medal winners. And the reason for this may very well be that it's easier for the silver medal winner to imagine having done just a little bit better and having won the gold. Right? There's a classic Seinfeld routine where he talks about how the difference between the silver medal winner and the gold medal winner is just often a fraction of a second. And so you can imagine that if you were just a fraction of a second away from being declared the best person in the world at your sport, how it would be really easy for you to imagine having done just that much better. Now, for the bronze medal winners, it's probably relatively easy for them to imagine not having gotten any medal at all, because the fourth place person was probably just a little bit behind them. So if they would have done just a little bit worse, then they wouldn't have gotten any medal. So that might be why the bronze medal winner is happier than that silver medal winner. So another fallacy that relates to this heuristic is called the first instinct fallacy. So this is something that you see students applying a lot when they are looking over their answers on a test. So you've probably done this yourself if you've ever looked over a test that you took and you saw that you changed one of your answers, that you had the right answer down, but then you erased it and put the wrong one down, and then got that question mark wrong because you had the wrong answer. You think to yourself, oh, I should have gone with my first instinct, right? Well, there's actually research on this showing that when people change their answers on an exam, like a multiple choice exam, they're actually much more likely to change them from a wrong answer to a right one than the other way around. So a little bit more than half the time, people do this. They change a wrong answer to a right one when they change their answers. And then the remainder of the time is divided up by changing right answers to wrong answers, but also by changing one wrong answer to a different wrong answer. And that's something a lot of people fail to take into account, is that you might do that. You had the wrong answer picked in the first place, and you just changed it to something else that's wrong. So for people who had the right answer and they change it to wrong, it's really easy for them to imagine having just left it on the right answer and having gotten credit for that. So they're extremely dissatisfied with the fact that that happened, and that tends to provide fuel for this first instinct fallacy, that they should have just gone with their first instinct. Although the research shows that if they went with their first instinct for everything, then their grade would probably actually be lower. That's just why that's a fallacy. Okay, so let's go ahead and talk about some other commonly occurring cognitive errors and biases. So the first one that we'll discuss here is called information overload. And this is something that has just gotten worse and worse as we can find a ridiculous amount of information on the internet. For example, when you're trying to make a purchase of some product. So many times we have too much information available to us to feel like we're really making the best possible informed decision. So let's just say, for an example, that you want to buy a new vacuum cleaner, and you're looking at your options and you see this fancy Dyson vacuum cleaner. It's kind of expensive, and you're thinking, well, maybe this is a good thing. I like having a clean house, but I want to make sure that this is a good product. So you go and maybe look at some product reviews online, right? So there are a couple types of information that you'll find, right? You'll find statistical information like customer ratings. You can go on Amazon and see the average rating provided by hundreds of different customers, sometimes even thousands of customers. And so you can just look at that star rating and say, okay, so this vacuum gets 4 out of 5 stars from 391 people, right? The other type of information that you'll see when you go looking for reviews is case histories. So these are just individual accounts provided by people. So if you scroll down a little bit further on those Amazon product reviews, you'll come across people writing up their experience with this product. So you can see some people praising the product and some people who had bad experiences. So here's an example of a negative review. Buyer beware. I forked over the money for an overpriced Dyson a couple of years ago. It's currently sitting in the closet and will go out to the curb for next week for trash pickup. So when you come across these two types of information, you kind of weigh their importance in your mind. And what tends to happen is that people give a little bit more attention to those case histories, those individual accounts, because of the fact that they are more vivid and interesting than that kind of stale, bland statistical information. So that idea that somebody spent $400 or $500 on this vacuum and it's they're throwing it out with the trash, it was a waste of money, that's something that really stands out to you. It grabs your attention and it sticks in your memory better as well. So that's why we tend to give those greater weight, even though the average rating might actually be the better bit of information to use. This is information that's gotten from more people. Maybe this one person with the bad experience, maybe they tried to use the product in a way it wasn't supposed to be used, or maybe they just got a bad vacuum, and most of them that are shipped are good quality products, but this one was bad. So just be aware that this is another thing that people commonly do. Now, our next cognitive error, or this is actually a bias that we'll talk about, is the confirmation bias. So this one is a very, very common problem. So what people will frequently do is they'll tend to notice and search for information that confirms their beliefs, and at the same time, they'll ignore information that disconfirms their current beliefs. So a lot of times we will believe that something is true, and then we'll go out into the world and we'll look for information to support our beliefs, because on a fundamental level, people love to be right and they hate to be wrong. I've talked about this before, like how with information about yourself, the strongest motive is self-enhancement, so you want to find good things about yourself, but second strongest was confirmation. So you have a strong motivation to confirm your existing beliefs about yourself. Right? So you'll tend to pay more attention to information that confirms your beliefs about yourself than that disconfirms it. One classic example of confirmation bias is in a study that was done by some psychologists, Snyder and Cantor, back in 1979. So they did an experiment in which they had participants read a description of a woman named Jane, just some events in her life, and she performed some behaviors that indicated that she was fairly extroverted and outgoing, and other behaviors that demonstrated that she was maybe a little bit more introverted. So just a range of different behaviors. So people read this description, and then a few days later, the researchers invited them back to the lab and said, all right, so you remember that woman Jane that you read about? We would like you to decide if she would be a good fit for these different jobs. And participants were randomly assigned to evaluate Jane for one of these two jobs. So they were asked to decide if she'd be a good librarian, here we are talking about librarians again, or a good real estate agent. So librarians are typically, again, considered to be more introverted. That might be a little bit of a stereotype. But real estate agents tend to do better if they're more extroverted and outgoing. And so the researchers asked people to remember specific behaviors that might be relevant to what's needed for these different jobs. And sure enough, people were more likely to remember the behaviors that were consistent with what was needed for the stated job. So if they were told, decide whether Jane would be a good librarian, they would remember the more introverted type of behaviors. If they were asked to decide whether she would be a good real estate agent, they would remember the times when she had performed behaviors that were more extroverted. So, again, this is a very common problem that people will do this. And it's also a problem with science. So you may remember in learning about the scientific method that it's good for people who are collecting data to be blind to the hypothesis, particularly in observational research. And the reason for this is that if they know what the hypothesis is, then they're going to be more likely to seek out evidence that supports that hypothesis, while ignore evidence that would go against the hypothesis. Now, another example that I'll give you, just to illustrate the next cognitive bias that we'll talk about, is I'll give you a description of a person. We'll say that her name is Anne, and that she is vegan, so doesn't eat any animal-based products, that she is a big fan of universal socialized medicine for all citizens. Let's just say she's an American. And that she opposes offshore drilling. Right? No new offshore drilling. Right? So which of the following, based on this description, do you think is more likely to be true? Do you think it's more likely that Anne is a Democrat, or that Anne is a Democrat and a member of PETA, People for the Ethical Treatment of Animals? Right? So many people when they're asked to make this decision, would say, well, these issues sound like they are things that Democrats would be more likely to support, but particularly with the veganism in there, that being a member of PETA seems to fit with that as well. So I think it's just more likely that Anne is a Democrat and a member of PETA. But this is actually an example of a fallacy called the conjunction fallacy. So the more specific that you make this category for Anne, the less likely it is that she is going to fit in there. Because keep in mind that people who are Democrats and members of PETA, that's actually a subset of Group A, the people who are just Democrats. So the safe bet here is that, well, it's more likely to be true that Anne is just a Democrat. Right? We don't know if she's a member of PETA or not. But again, because it sounds like it might fit with your stereotype of somebody who is a Democrat and somebody who's a member of PETA, you might be tempted to choose option B there, that Anne's a member of both. So the textbook definition of the conjunction fallacy is that we tend to see something as more likely as it becomes more specific. So let's go ahead and look at another commonly occurring problem with thinking. This is called an illusory correlation. Now, as we are going about our lives, we have a tendency to want to explain the things that we see. We especially like to come up with cause and effect type explanations. So we will observe a lot of different things, and we will come up with possible relationships between them. And sometimes, this is accurate. Sometimes it's not. Right? So we have a tendency to overestimate the strength of the link between variables that may only be slightly related or not at all related. So one reason that this happens is that rare events tend to be especially noticeable or memorable. And one experience that a lot of you have probably had is when you get an unusual phone call, and maybe what was happening is that you were thinking about someone or talking about someone with a third party, and then they call you out of the blue. Like, you didn't have this phone call arranged in advance. And you think, oh my God, that's so weird. I was just thinking about you and you called me. And sometimes people will joke and say, maybe we have a psychic link between us, and that's why you called me, is you could somehow detect through time and space that I was thinking about you, so you felt the need to call me. And that can seem like an exciting possibility, right? But let's just think about all the possible combinations of these two factors, you thinking about someone and them calling you. Right? So there are rare occasions when you think about someone, and right when you're thinking about them, they happen to call you. Then there are also a lot of occasions when you're thinking about someone and they don't call you. But that's not going to be nearly as memorable as the first combination, right? It doesn't seem like there's anything special about that. And then there are a lot of times when you are not thinking of that person and they call you, right? But you don't get that phone call and say, oh my God, this is so crazy. I wasn't thinking about you, right? And then there are also those times when you're not thinking of someone and they don't call you. And there's really nothing at all special about that. There's nothing to remember, right? You weren't thinking about someone and they don't call you. Now, in just thinking about which one of these is going to be the most common, well, probably not thinking about someone and they don't call you. All of thinking about someone and they don't call you, not thinking about someone and they call you or not, those are probably far more common than you're thinking about them and they just happen to call you. But again, that one combination, because it is so rare and weird sounding, does tend to stand out in your memory. So that can support some of these sort of odd beliefs that people will develop about psychic links that they have with other people. All right. So, if we were actually in a classroom right now, I would do a little demonstration with you, do a coin toss. So, we're not, but I actually have a coin right here. I'm going to get a penny, right? And I'm going to flip this a few times. All right, I'm starting off on heads. I'm going to flip it. Tails. All right. Let's see what happens next. Heads. Heads again. Heads again. Right. Now, if you had to guess what will happen on my next coin flip, we had a tail, heads, heads, heads. What would you guess is going to happen next? Which is more likely, that I'll get heads for the fourth time in a row or tails? Right. So a lot of people would say, oh, tails, you just got 3 heads in a row, so things are going to balance out. You'll be more likely to get the tails next. When the correct answer is that you don't know. It's a 50-50 chance every flip of the coin. It could be another heads, it could be another tails. The fact that I got 3 heads in a row doesn't affect the likelihood that I'll get heads or tails on the next toss. So this is what's referred to as the gambler's fallacy. It's just this belief that people have that chance events are affected by previous events and that things are going to even out. Another way that this can happen in people's thinking is that they'll think that you're on a streak. So maybe you're on a hot streak with these, flipping heads, and you're going to get another one. There's a phenomenon that some people believe in basketball called hot hand, when players will be particularly successful in making baskets. They'll think, this player's on a streak. But again, particularly with the example of the coin toss, it's just a completely chance event. So if you believe that previous events affect that, that doesn't make any logical sense. I've also seen this happen on tests. So for example, when I'm making a test and I'm choosing where the correct answers are going to be, whether it's A, B, C, or D, I just do that completely at random. I don't really put a lot of thought into what's going to come next. But when students are taking a test, they'll think that, maybe they'll assume that it should be random and that there won't be these long streaks of the same answer. So if you look down at your answer sheet and you see 5 A answers in a row, you'll think to yourself, oh, I must have done something wrong. You can't possibly have this many A's in a row because it should just be a chance event, right? But sometimes that just happens, and it drives students crazy. But it's just like you can flip a coin and get 5 or 6 heads in a row. It just happens, and the fact that you got 3 or 4 heads does not affect the likelihood that the next one will be heads or tails. It's still 50-50. So the next bias or error that we'll talk about is called the false consensus effect. So this is a tendency that people have to overestimate the number of other people who share their opinions. So we tend to believe that lots of other people think the same things that we do, think in the same ways that we do. So one way that this might be relevant to you is if you are a politically minded individual and you're paying attention to the current presidential primaries in 2016, you might try to think about how many of your peers would vote for the same candidate as you would. Right? And you would most likely see the false consensus effect, such that people would overestimate the number of other people that support the candidate who they support. Right? And you can see this for just about anything. If you look at people's favorite food or the sport that they like, they'll tend to overestimate the number of people who share that opinion with them. All right. So the next one that we'll talk about is called statistical regression. So if we look at what happens after extreme events, what we can see is that they're usually followed by events that are less extreme or closer to the average. Right? So the classic example of this is what's called the Sports Illustrated curse. Right? So there's this belief that people had that being featured on the cover of Sports Illustrated is actually a bad thing because, and in a sense, this was actually supported by data. So what will happen is athletes will have a really impressive performance. They'll do extremely well, and then they'll get featured on the cover of Sports Illustrated, and then after they're featured, their performance will go down a little bit. They'll start playing a bit worse. But what's probably really happening here is statistical regression. So the reason why why athletes are featured on the Sports Illustrated cover is that they are performing exceptionally well. But just statistically speaking, those extreme events, that extremely good performance is going to be likely to be followed by a performance that's not so great, not necessarily bad, but just closer to the average level of performance that's demonstrated by athletes in that particular sport. So it isn't anything that's caused by being featured on the cover of Sports Illustrated. It's just caused by this natural tendency that people have to alternate between success and failure. All right. So another type of error in thinking is called magical thinking. This is when people have assumptions about the nature of the world that don't really hold up to logical scrutiny. And there are a few kinds of these. One is contamination fears. So people will have these irrational beliefs that certain objects will pass on properties to one another. These are just ideas that are not supported by science. One classic example of this is a house that somebody died in. So some people will be superstitious about this. They'll think that there's something that must be bad about this place because someone died there. Something bad happened there in the past, so maybe it's haunted or something like that. Another example of this is when I was in graduate school at Florida State University, there was this really spooky-looking abandoned hospital, and there were a lot of rumors that it was haunted, which that's of course magical thinking in its own right, very superstitious, not supported by science. And then that was torn down, and an apartment complex was put up where it used to be, just on that same plot of land. And so people that knew that that abandoned hospital had been there were kind of superstitious about the apartments that had been built. They thought, well, because it had been on the same ground as this kind of spooky hospital, maybe those apartments were haunted. Something passed on to that land based on what was there before, when realistically that's completely goofy. There's nothing that's going to be wrong with those apartments just because they're built where this abandoned hospital used to be. Another example of this kind of contamination fear is when something resembles something else that shares some basic properties. One example would be worms and dirt cake. So it's like cake with gummy worms and like crumbled up Oreos to look like dirt, right? So there's actually nothing dirty about this. All these are perfectly clean, edible things, gummy worms and crumbled up Oreo cookies, but because it resembles something that would be disgusting and dirty, a lot of people might think that this is less appetizing, when really, objectively it's not. It might be less appetizing, but there's no logical reason why it should be. If you just think it through, it's just regular food that happens to look like something that would be dirty. Okay. So another common bias that people have is with counterfactual thinking. So people, when they experience an event, will often be tempted to imagine what could have happened, right? They'll imagine alternatives to past and present factual events. Right? So if things had been a little bit different, how might my life have turned out? And there are different ways of doing this. There are downward counterfactuals. So this is when you look at something in your life and you say, well, it could have been a lot worse. Things could have happened differently, and then I'd be worse off than I am now. Then there are also upward counterfactuals. So this is when people think to themselves, well, I could have done things differently. It could have been better. Now, these are counterfactual thinking examples because, people are thinking about things in a way that did not actually happen. So you can't actually say it could have been worse or it could have been better because, it just is. You don't know that it actually could have been any worse. Maybe that was the only thing that could have possibly happened. Same for it could have been better. Maybe things just are the way they are and it couldn't have been any different regardless of what else happened. But between the two, upward counterfactuals tend to be a little bit more productive in that they can help people plan their future behaviors. So you can look at something that had gone wrong and maybe do things differently in the future. So one example might be if you've ever been in a big hurricane. If you're stuck in this storm and you don't have any emergency supplies and your power is out for 3 days, you're going to think to yourself, well, it could have been a lot better if I had just prepared for this storm better and gotten a supply of food and maybe a generator. I would have been much more comfortable in the aftermath of this big storm. You can also do downward counterfactuals and say, well, it could have been a lot worse. I was without power for 3 days, but my neighbors next door, they had a tree fall on their house. So that didn't happen to me. But just between those two, again, the upward counterfactuals tend to be more productive for the reason that I mentioned. Right. So let's start to wrap this up by just talking about how serious these errors really are. All these errors in thinking that we've talked about. So a lot of the decisions that we have to make day in and day out are kind of trivial decisions. And for these, there's really nothing wrong with using these heuristics and automatic processing. These are just little decisions that aren't really going to affect other people or even have a big effect on our lives. Like the decision of whether somebody is a librarian or a Texan. That was just kind of a silly example. But then there are also some times that we have to make very important decisions, like whether you're going to hire somebody for a job. And so if you are making a decision that's going to affect other people, it's a good idea to try to avoid these errors in thinking. Or maybe a decision that's going to result in an investment of a large sum of money. So you probably want to make an effort to use conscious processing rather than just going with your automatic system. And try to be aware of the fact that we often use these shortcuts and just try not to use them. So spend some time getting all of the relevant information and thinking critically, questioning your decisions. Why do I think this about this person? Is that actually accurate, or was it driven by some bias that I have? And so the bottom line is that when possible, you should try to think critically. You should consider multiple alternatives to your ideas instead of just going with your gut. Right? When you are trying to think critically, it's important to rely less on your memory. Because we know that memory is not perfect, it's often biased, and don't rely, like I said, on your automatic system. Try to think consciously. Actively seek out information that could disconfirm your beliefs. This is something that we don't like to do. It does not come naturally to us at all. Like I said, we have a confirmation bias. So when we're going out looking for information that relates to our beliefs, we tend to avoid disconfirmatory information. So if you actually actively seek that out, that can be a helpful strategy for critical thinking. And then finally, just try to take some of these biases into consideration by just being aware of the biases that you have. and stopping to think about that can actually help you to avoid some of the problematic patterns of thinking that are associated with them. Right. Well, thank you very much for your attention, and have a great day.